Welcome in, guys. I'm gonna be gone for a few days, so I wanted to at least do a couple of videos here so that you can get a feel for the material that we're going to be covering here. So let's go ahead and take a look at 6.2, which is the binomial probability distribution. There are four criteria that this kind of probability must meet. Number one is that n trials are performed. Okay, so very simple. If you were to toss a coin 5 times, then that would be the number of trials, would be n equals 5. Each trial must be independent of all others. That meaning that if we got heads on the first toss, does that change the probability of getting heads on the second toss? The answer is no, it doesn't. It's the same each time. Each trial results in either a success or failure. So if we toss a coin once, it either results in either a heads or tails. Okay, heads being a success, tails being a failure. If we observe airplanes being on time from one airport to the other, each trial would result in a success or a failure. So if the plane was on time, it would be a success. If it was late, then it would be a failure. Okay? All right, and then the probability of success must be the same for every single trial. All right, so for the probability of getting a heads, it would be a half, and this condition must be met. So these four conditions must be met for something to follow a binomial distribution. And what we say is, we say x follows a binomial distribution with two parameters, n and p. N is the number of trials, and p is the probability of success. So you'll see those right here. And then this is the formula that we're going to use. We're not really going to use this the way we read this. I'll show you how it works, and I'll show you how to do it in the calculator, and then we'll look at StatCrunch. We've got n choose x, p to the x power 1 minus p to the n minus x power, where n choose x is this formula over here where we have n factorial. And a factorial, if we have 3 factorial, this is just 3 times 2 times 1. So you can kind of plug in the numbers and get this number here. These two here we don't have any trouble getting. It's just some number to a power and 1 minus p, which is some number to another power. These two are fine, so we want to know how to get this guy. And so p is the probability of success on a single trial. N is the number of trials, okay? And x is the number of successes. And the mean is very simple to calculate. It's just n times p. So I'll show you how to do that in a second. And the variance is real easy too. It's just np times 1 minus p. So let's look at a very simple example here. Let's say we have a binomial probability experiment with the given parameters. Compute the probability of 38 successes in the n independent trials of the experiment. So we have 40 trials, and the probability of success on a single trial is 0.99, and we want to know what's the probability of getting 38 successes out of the 40 trials. Okay, so we can do that like this. What's the probability that the number of successes x is equal to 38 is equal to n, which is 40, choose x, which is 38, times p, which is 0.99, to the power of x, which is 38, and then 1 minus 0.99 to the 40 minus 38. And we can simplify 40 minus 38 and get 2, and then we can compute this. This n choose x here, just to show you here on the calculator. You can calculate that by going to math and then go over to probability, and it'll be n choose r. So you'll hit option number 3. And then n is 40. Scroll over, and x is 38. And and enter. So that's where I got the 780 from. Okay, so we just get 780 times 0.99 to the 38th power 1 minus 0.99 to the squared. And over here I show you how to do that by hand, that N choose R button from the calculator. You don't really have to worry about that, but you can kind of note that. So the probability is 0.05. All right. Now the mean, how do we calculate the mean? It's just N, the number of trials. So the number of trials times the probability of success, P. I'll do that in green. Okay. So we just plug in N times P, and the mean is 39.6, and then the standard deviation is just N, P, 1 minus P. All right, so let's take a look at, now this example here that we just did, I kind of gave you the parameters. And so now we're going to look at an application problem where we have to come up with the parameters on our own. So let's say that we take a 10-question multiple choice test, and for each question we have 4 possible answers, A, B, C, D. What's the probability you at least pass? So I've done that here, you know, question 1, A, B, C, D, question 2, A, B, C, D, and so on and so forth. And we've got 10 of these, and we'll say that passing is at least 7. 7 out of 10, 7 out of 10 would be 70%. So we'll say that's passing. And so then question. Okay, question here. I want you to think about it. What is the number of trials? Remember, that's criteria number 1. N trials are performed. Well, if you take a 10-question multiple choice test, then each time you guess a question, question 1 would be a trial, question 2 would be a trial, and so you'd have 10 trials. So number of trials would be 10. And then the probability of success, P. What is the probability of getting a single question correct on one of the problems? Well, there's 4 possible answers, A, B, C, D, so 1 out of 4 would be the probability, or 0.25. Okay? And so they're all independent. If you get the first one correct, that doesn't change the probability of getting the second one correct, and so on. And we assume here that, of course, we're strictly guessing. This is kind of a neat question. If you guess on a multiple choice test with 10 questions, each one has 4 possible answers, what's the probability you at least pass? Well, let's figure that out. Okay, so we say that X, the number of correct questions, X, follows a binomial distribution with N and P. And so N is 10 and here. So P is probability of success, 0.25. So what's the probability that the number of correct questions, X, is greater than or equal to 7? Well, this is going to be the probability the number of correct questions, X, is exactly equal to 7. Okay, because if you took a test and you got exactly 7, you would pass, plus the probability of getting 8 questions correct. So X, the number of questions, is equal to 8 plus 9 plus 10. And it's very tedious here. Because you would have to do that big long formula for each one. So notice for this probability here, you have to type in all that, and then for the next probability over here, for 8, you know, you have to do all that one, and then so on, 9 and 10. But what we're going to do in class, and especially for on the test here, what I'll show you, we're going to use a formula. Tables and formulas. So let's go to your tables and formulas, and we're going to look up N equals 10. So I'm going to show you over here. Binomial table, table 3. Now notice something. We got N equals the number of trials is 2, 3, 4, 5. X, the number of successes, can be 0, 1, 2 for 2 trials. And notice here, you can't have more successes than you have trials. So if you have 3 trials, if you have 3 questions or toss a coin 3 times or look at 3 planes or whatever, you can't have 4 successes, and so that makes sense. And then across the top we have the probability of success, and it tells you the meanings of all this over here, X successes and N trials. So let's find N equals 10. Okay, right here is n equals 10. And we're going to look at x equals, so this column, remember, is all the x values. Okay, so we're going to look at x equals 7, 8, 9, and 10. For p equal to 0.25, so 0.25 is this column. So we're going to look at, this number is probability you get 7 plus 8 plus 9 plus 10. And you might be thinking that it's not 0 that you get 9 or 10 questions. It's just really small, so that's what the plus means. So that means we just go back over here and add these up, 0.0031 and so you'll see there that, so these numbers here, these numbers I just read off the table, okay? Just read right off the table. You add those up and you get 0035, okay? Of course, the mean, again, very simple, just n times p. So number of trials times probability of success is equal to 2.5. All right, so let's take a look at, this is example 35. It says, according to flightstats.com, American Airlines flights from Dallas to Chicago, so we go from Dallas to Chicago, are on time 80% of the time. So the probability of success is 0.8. Suppose 15 flights are randomly selected and the number of on-time flights is recorded. So we got number of flights 15, so n is 15. So we've got n and p. So we can say x follows binomial with number of trials 15 and probability of success p. So find and interpret the probability exactly 10 flights are on time. So what's the probability that number of on-time flights x is equal to 10? All right, and so we're just going to look this up here from our table. So we're going to go down to n equals 15. Number of trials is 15. And x equals probability, p equals 0.8 probability of success, and x equals 10. So we get 1032. That's the probability of 10 planes out of 15 being on time for any given group of 10 planes. And then we get that, okay? So find the probability that fewer than 10, okay, so number of flights x is less than 10, fewer, means that x is less than or equal to 9. So 0 flights plus 1 flight plus 2 flight plus 3 flight, so on and so forth. So this is what we want to do, is add everything from 0 up to 9. So we'll go over here and add everything from 0 up to 9. All right, so let's go n equals 15, p equals 0.8. And so we're going to go from 0. So this is 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Okay, so we're going to add all these probabilities up here from 9 to 0. And we do that, we add all those up. Then you get this sum here. I just went ahead and added everything up. That's the sum of all those probabilities. Okay? And now we'll find at least 10. So at least 10 again means 10 or more. Okay, so now we're just going to add up probability of 10 plus 11 plus 12 plus 13 plus 14. And so again, these numbers here come right from the chart. So that's all you have to do for these, is to just look right on the chart here. So 10, okay, 1032 plus 11 plus 12 plus 13 plus 14 plus 15. Okay, so let's go back over here, and there are the probabilities, and we add all those up and we get this number. All right, find and interpret the probability between 8 and 10 inclusive. So that just includes 8 and 10, right? Inclusive. So that means x is between 8 and 10, including, so the equal to sign, 8 and including 10. So that's going to be probability of 8 plus probability of 9 plus probability of 10. And so again, we just look on our table, look up the probability where x is 8, add that, plus that, and we get that. Now the mean is here, is n times p, and actually it's supposed to be 80 here. Let's see if my math is right. 15 times 0.8 is 12, so let's change that. Change that to 80, and that makes that 12. Okay, so the mean is 12, and so what that means is, and we'll change it down here as well, that means if we look at a whole bunch of, well, the probability, let's see, the average would be 12. So if we look at a first group of 15 planes, maybe we say 10 are on time. Another group of 15 planes, maybe 8 are on time. Another group, maybe 13 are on time. And then another group of 15, maybe 9 are on. And we average all these up, we should get 12 over the long term. That's kind of what the average means. Now, let me show you a couple homework questions over here. Let's look at number 4. I want to show you how to do this very quickly in StatCrunch. So let's open up StatCrunch. And we got 50.02 in X. There's a really nice calculator, and you'll love this calculator over here. So we'll go to calculators and we'll hit the binomial. And all there is to it, literally, we're just going to type in 50, and then P is 0.02. And then you can change, so you can choose if you want to know less than or equal to, greater than or equal to, less. I'll show you how great this is. It'll make the homework very, very, very easy. So we want to know exactly equal to 2. Where's my StatCrunch here? Exactly equal to 2. Okay? And the nice thing about it is you can just copy this right on over here into your homework and paste it in. You'll love it. Round to 4 decimal places. So 1858. Okay. Fantastic. And so let me pick one over here where we have maybe less than. So what we'd have to do is add up from the table the probability that x is equal to 0 plus 1 plus 2 plus 3, because we're stopping at 4. But let's watch how easy this is for the binomial calculator in StatCrunch. So n equals 7, p equals 0.5, and x is less than 4. So n equals 7, p is 0.5, and we want to know less than 4. Compute. And let's make sure that's n equals 7, p equals 0.5. Okay, so that's a half. Okay, so you can see how easy this is. Okay, so now we change the parameters here. All right, and so now over here we want to fill this in. Of course, here I'll show you this. You could either use the calculator and go through each time, but the easy part would just be to fill these in with the table. N equals 9, p equals 0.2. So all you'd have to do this one is go over here to n equals 9, p equals 0.2, and just fill in. X equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that's it, folks. I mean, that's all there is to doing the homework here. So I hope that the by hand, the table that we've used, I hope you understand the table. It's fairly straightforward and simple. And then, of course, the binomial calculator will help you with the homework. And so just practice with the with the table and with the homework. And then I'll see you guys in chapter 7. Okay? Have a fantastic day.